bloop. So we've got three questions left. So find the acceleration components for both tangential and normal components. But notice this one's fun and interesting here. Do you see the tiny bit of difference between the other ones? It's very tiny. What's different from this one than the last one? Can I go back up and look? Oh yeah. Oh yeah. What's the difference? Tiny, tiny difference. Isn't yeah, blah blah blah. There's a lot going on. What is it? Fundamental. Well, kind of. It's that circle right there. So So yeah, well yeah, there's a shape here for sure. This is definitely circle-like, and then it's growing this way along the y-axis. Yes, exponentially even. So it's like a tornado almost. It's also at 0. This will help us. It makes it much faster when we can use that. Okay, so there's going to be a moment where things are all cluttered, and we just plug in a 0, and woof, it makes things better. I don't know if we did that, but like sometimes we have to simplify, 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 simplify. We don't really have to do that here. Okay, we're going to just make a big mess, pop in a 0, and hope for the best. Okay, so that's a good thing right there. So I need to go get formulas because I can't remember them. I know y'all have them, but I'm just going to go back and refer back to what we got here. These on the last section were way better. So I got the dot product and the cross product. Good? Okay, good. So let me scroll them back then. I'll write those up and then figure it out together. There we go. So AT was the dot product of, you're going to remind me, was it R dot V or is it A dot V? V dot A? V dot A over magnitude of V? Okay, and then AN was magnitude of V cross A over magnitude of V. Okay, cool. I dig it. Put a little bit of vector action in there. All right. So we have our R. I guess we're going to have to find our V. So y'all help me now. What's the derivative? Oh, look, there's a... Did we have this last time? Did we do this already? We didn't do this one. It looks so similar. I thought we had done the product rule thing before, haven't we? Oh, I see then. Then help me a little bit. So I'm going to go F prime G plus FG prime. What would I get then? You're okay.
So the first would be 2e to the t cosine t.
Cosine T?
Yes.
So you're doing G prime?
Oh, yes.
Okay, that's fine. And then plus?
Then plus 2e to the t sine t.
Cool, cool. Let me clarify for the folks at home. We did the other way. So this was F G prime plus F prime G. That's what you did?
I believe so.
And scalar addition is commutative, so we're good to go. I know, little things like that. Derivative over here.
Wouldn't that just be 2e to the t square root 6?
Yeah, no changes. Very good. And the last one? James is waiting for y'all. Perfect, perfect. Very good. And I like how you put it in that order. That was very good. I was hoping for that. Yeah, so this time here, now we have F prime G plus F G prime. And that makes more sense because of the minus sign over there. Very good. Excellent. And then now for our A, R double prime. Oh, pause. Now, Yeah, exactly. Let's literally pause for a second here. You can see that we're going to be getting into a mess, but that's exactly what I was warning you about, right? We're going to have a huge mess. We're going to mush it all together, and then we put a 0 and we're done. Okay. So I think that we can probably plug in that 0 before we even do the formulas. As in, we can have this at 0, this at 0, 0 at 0 at 0, and I believe we don't need to do a dot or a cross product with t's ever. Okay, that's my thoughts. Are y'all willing to try that with me? Okay, so we'll plug it in after we get this guy. So this one's nuts, but notice that this guy will be a duplicate of what we had originally, and then this cosine is going to be a duplicate of this guy over here. So I'm literally just going to like do that for just a second, okay? So I'm duplicating this over here. Oh, of course I can't even do that right. And then plus, and then I'm going to duplicate my original over here. Okay, comma. The middle term doesn't change. Nice. And then we got this junk again. So, the first one is going to be a duplicate of the original that we had. But then the derivative of this one is the same as this guy here with the plus sign. But there's a minus in the front. So I'm going to put a minus in the front and then duplicate that one over there, basically. Okay, awesome. Yeah, that's a lot. Do y'all have enough paper?
No, it's a lot.
Mm-hmm.
I'm still writing down names.
I know, right? Yeah, I'm gonna give it a minute here. So our goal here in just a few seconds is we're gonna try to cancel, combine something. Yes, we can plug in 0 right now. I get it, but I think that a lot of this, well, you know what? It's 0, right? We're not plugging in like 2 or 3. 0 with sine or cosine, I think that we're going to get some pretty nice results. So I don't want to simplify. I don't care anymore. I want to just get the numbers. I'm going to plug in 0 and hope for the best. So let me get a different color for that because it's going to go pretty crazy now. Oh, yes. I mean, yeah. If you see it, let's go ahead and do it then. If you like canceling, I like canceling. So what would cancel on this first chunk? The sines, yep. And then over here, the cosines will cancel. You're right. Whenever you distribute that, and then those would combine together. Okay, that makes sense. I like that. Let's do that. Whatever makes it easier, right? When I plug in a 0, and let me just have this up as kind of like a formula up here. So cosine of 0 is a, and sine of 0 is sweet. So anything with a sine in it, gone. Okay? And anything with a cosine just keeps its ET business, right? So cosine is going to keep it. Sine goes away. This guy. I should probably, back up because we can even make that even easier, right? Oh, not t, of course, 0. But yes, e to the 0 would be a 1. So yeah, we can make it even easier. You're right. So then that's a 1. That's a 1. So I got a 2. Literally, that's it. This right here. Perfect, perfect. And then this guy, the sign goes away. Just another 2. Man, this is going really well now. Same thing here. Now notice we have 2 2s. 4. I was waiting for it. Same thing. And then right here,
So I'm lost in this chat.
It's so much, isn't it? That's why we're trying to break it down with the zeros. Completely understand. What we get in that last term? It's almost devious. 0. You got it, because those are signs. Those are 0. Man, I was thinking -4, -4. I was waiting for him to say -4. You're right. No, you're wrong. Sorry. It's 0. Yeah. Do you see the strength now of having it being a 0 in the front, right? That really is going to help us. And so now I'm going to simply do some dot and cross and other little happy times. So here we go. I'm just going to slowly do some of that stuff on the side now. But no rush at all. So when I dot them, I get 8 plus what? What would be that number there?
Oh, there.
24, very good. That was great. Yeah, that's very good. Okay, now I'm going to cross them. Go on. And again, because there's so many like moving parts, it's okay to go slow. Except for on an exam. Then you're not going slow. Bad, Chad. Stop talking about it. 4 square root 6 regular k, and then we got a 0. Anything times 0 is 0. 8 square root 6. That's going to be a negative k. Yes, negative k. Always a 0. 0 times anything is 0. Regular roll 8. I think that's the regular J position. I should probably have written all that out beforehand. Yes. Yeah. It's kind of like the opposite diagonals, you know? Kind of weird. So all my I's together, all my J's together, and then all my K's. What would I get for K? See. Yep, -4. Yep, you got it. Very good, very good. So we got this guy. Now I need to find the magnitude of that. I know, right? Oh, you know, there's 2 of those guys. I'm going to write it up anyways, since I don't want to squish it. Oh, maybe. Yeah, it's going to be a lot. So exactly, we got 16 times 6 is 96, and then no, times 2 though. Okay, hold on. That's time for a calculator. Hold on, I don't know. So yeah, 16 times 6, but then times 2, because there's 2 of them there. And then plus the 64. I love when it comes out the powers of 2. Bam. Right? That is right, isn't it? Okay, good. I feel all confident and stuff. Oh, isn't that kind of nice? They're half of one another there. Yet, those are not my final answer. Those are still just components. Now we have to find the magnitude of V. So let me go ahead and do that. So my original V was this guy. Now I have to find this magnitude. take very good notes while you're doing your exam. Oops, that would just be times 6. 24. It's easy enough. 8, and that would be what, 32 again? But that does not easily, that's not a nice square root. Is it 4 square root of 2, I think? I think so. Good point! What am I doing? Gross! Yeah, I know, right? Yuck, Chad. Yeah, so there's my last component there. And so AT would be the 32 over the square root of 32, final answer. And then my AN is the 16 over square root 32, final answer. And let's just verify. I'm going to flash the answer here. Right? Now, let me just verify. This one would be double that one, right? So if I pop this and leave the square root, yep, yeah, that would work. It's good. Awesome. Whoa, that was a lot. Are y'all getting it? See that? See the power of the 0? Mm-hmm. When I see that, I'm like, oh yeah, this will be much better than what it could be. Oh no. I know. I know we're in Cal 3, but you know. This isn't Cal 4. They don't do that in Cal 4 either. You're like, what's calculus 4? Differential equations. I just wanted to let y'all know. Oh yeah, no problem. Yeah. Yeah, differential equations, calculus 4. Yeah. Well, that's it. Once you hit, I mean, because they don't even label it anymore. They just diffie Q. You know. Yeah. Cool. Yes. Yes, exactly. Hopefully you do. Any questions though? Are we cool? Okay. 0. I'm serious. On an exam, don't freak out. When you find that, you're like, got it. You know what I mean? It really is a longer. This question right here is no longer on your homework. It's not on the quizzes. It's nothing. It wasn't on the quizzes to begin with. But there are these B ones, and we're just going to do this and find B. Okay. The formula for B, I think, is just cap T cross cap N. I'm going to just verify that right quick. Yep, right there. There it is. There are 2 of those on the homework. They are not on quizzes. They're not on exams. But I do want to talk about it just a tiny bit and make sure that we can make a cross product, I guess. So we're going to do this one. I might not do the last one because I get bored. Because the main part was for this tension, but the torsion. But it's way too much for us. Okay, so what is B? Again, we have a curve, and we have a tangent vector, and then we have a normal vector. Oh yeah, it's going into the curve, that's right. But then, and this is not, you have to see me in person for this, of course, but I'm going to start at T, go to N, and then my normal vector is coming out towards the page, out towards your eyes from the page. So, right there. So let's do it. Let's do. You know what? You know what? I want y'all to do that. That's a you do. Y'all are already doing it. I didn't even have to say anything. Good time. This is a perfect opportunity. That's it. Yep. And you got DNA. Yeah. Exactly. Yep. Should be pretty straightforward. I don't think the homework. Okay, you know what? I'm gonna verify if you don't mind. While being recorded. Let me go to there and see what those questions look like. Homework. Right here. Only 6 questions on the homework. That's kind of nice. nice. Yeah. Here, now you can see what the questions look like. Yeah, none of y'all are looking. See, T and N, don't they look the same? It's just the only difference between this and the other ones that they don't have the torsion part of it. But see how they're literally identical? So even with the sines and cosines. So that's your homework. You're good to go. We're doing the right thing. Already done? Good. That's good, though. That's good. In the end, I think a lot of it cancels, doesn't it? The K's cancel? Oh, not the K's.
Well, there's like the sine squared plus cosine squared.
Right. Right,
Yes,
right.
wouldn't that just reduce it down because you could factor the -4/5 instead of just the 4/5?
Yeah. Or whatever. Yeah.
At least that's what I got.
Cool. Now I wanted to go and do it. You know what? I do want to simplify this a tiny bit. They all have a 5 in the bottom. And I'm going to do this. And that way I have like whole number integer thingies to work with for me. But before I do that, first off, I don't want to like jump ahead and leave you behind. I want to make sure y'all are okay with me to start. You good? What if I did this and factored out of this one? Would my result be different for doing something like that? So this right here, that symbol, and I'm talking, go back to kindergarten for a second. What does that mean right there? What does that symbol mean? Multiply. Is it okay to have something on the front and multiply it in a way like 1/5 times? And not distribute necessarily. Yeah, distribute, but like just times. So in a way, I'm just making it easier, and then I'll just put a 1/5 at the end and call it a day. So let's do that. So yeah, this just makes it easier on my math. Sine times cosine makes nothing. It's just sine times cosine. Bad Chad.
Well, wouldn't with this one, since it's I times I, wouldn't that be 0? Since we're cross multiplying?
Oh my gosh, you're just so smart. I was thinking this one ahead, but then yeah, thank you. It was a 0. It doesn't matter. Silly Chad. Sine squared, and that's a K. And then I got a 0, so that's kind of nice. Cosine squared. Guess I got to put a T in there once in a while. Notice
that one's negative.
So yeah, this would be a negative, and then I had a negative, makes it a positive. So I was going overzealous for a second there. Start over. So yeah, 2 negatives will make a positive, and that's now again just a K. Always a 0, and then anything from 0 is 0. 3. So then this is going to be the positive J. So it'll actually end up being a negative in the end there with a 3J. And then 3. This is the negative sign, so it's actually going to be a positive. 2 negatives cancel. Put a 3 in the front. And then a 0. Okay. Do you concur with what I have here? And then this junk. What do I get for my K? Because I'm factoring Yep. It's just going to be a 4 because I basically factor out the 4 and then this is just a 1. Cool. But silly Chad, this is also wrong still. What did I do wrong? There it is. Man, how many times? How many times do I get stuff wrong because of that sort of thing? Yep. So 3/5. I'm going to be official here. Negative 3/5. And then just 4/5. Is that what y'all got?
Yes.
Okay. And then that's B, isn't it? Cool. Didn't that look a lot like my T? Oh, it's just different sine cosine. No, it's still sine cosine. Interesting.
Just the values of the numbers up front are different.
Sorry, I was just looking at it. And real quick, let me flash the answer. Just verify that we got it there. Yep. Then again, we're not doing the torsion part, so cool. Yep. Looks good. Looks good. I don't want to do the last one. It's really the same thing, but I do want to mention. There's a mention here. Okay, we don't need that. Notice the 13 in the bottom. Like for one thing, they all have a 13, so we can factor that out just like last time, right? But just because it looks like a fraction, it just means it's a number in the front. It's 12 over 13. You know, so like don't let your eyes deceive you. That's all. Cool. Okay, cool. One other thing, since I'm not gonna do this one. I'm gonna talk about it though. Notice it's like 2t, 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 2t. If everything's the same, what I often do and what you didn't see me do is sometimes I just write sine and cosine without the t because there's already so much symbology going on. The less is more. Okay. And it is appropriate sometimes to do that if it's been a really big. Go ahead.
So long as all your cosine and sine
Are the same.
have the same internal value.
Exactly, and that's why I specified 2, 2, 2. Everything's got a 2. We're okay then. Very good. Yes, and I have been known to break stuff down just with C's and S's. Yes, I know, how bad of me, but you know when you're going fast, I mean, and you're doing trig stuff, man, pop, 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 you can get it done, and not have so much confusion going on. Cool. That was it, because I'm not doing that one, so then we're done. Yay. I have something from the homework that we can do. Do you want me to start with that, and then y'all can maybe do the next one, kind of thing? Like basically, like you tell me what else you want me to do. Okay, good plan. Okay, so let me go out of this and back to. I know, Chad. There's a button at the top that all you need to do is click. Yes. Or I could scroll forever. I know. So this one. This was a fan favorite. Is that okay? Good one to talk about? This is question. It's question. Obviously, it's question. Question 8. Yes. Number 8. 3.2. Why don't they put question number up there? This is just so weird. Let me get a blank page. So I'm going to do blank page. No. Blank. And back to the homework. And let's do this. Okay, awesome. So yeah, let's talk about this one. They give us this d squared r dt squared. What does that mean? Second derivative. So that's Leibniz notation. Yeah. So what would it look like in Newtonian notation? Yeah, double prime. Very good. I mean, wow, a lot easier, huh? But there's strengths to both. There's strengths to both. If you've done calculus 2, maybe some Cal 1, I really hope that your professor showed you some of the strengths of Leibniz. Yes. Oh, because yes, DiffEq, you have to have Leibniz notation to move things around. But really, you actually use both. It's kind of weird. It's like a mixture of the two in DiffEq. True, true. Yeah, we should definitely be familiar with both. So yeah, we got our double prime, and this one here is kind of lengthy looking. Sweet. What they want eventually is just R. So we're going to basically integrate, and we're going to integrate again. Are we doing a double integral? No, I'm just no, not yet. But yeah, we will integrate twice for sure. And then they give us these initial conditions, which we'll be plugging in here in a second. So let's integrate. So my R prime, what would I get? Easy enough. Yes, yes, I like that. 3, very good. You're dividing by that number. Yep, exactly. Normally we take that number and multiply it down here. Now we're just simply dividing by that number down there. So you take it, divide to get a 9 to a 3. Yep, very good. Now, what we're doing is plus C, and normally I would say, oh, initial condition is my C. That's great for a lot of them, but not here. I wouldn't assume that because we have e's, or we have sine cosines. Basically, they would call them, I think they're called the transcendentals. So we got things that are not polynomial. And so, yeah, we can't just say, oh, well, that's my initial condition. But I can say that this whole thing equals -1, 4, 0. And then I solve for C. At t equals 0. I should probably specify that. There we go. Little things, little things. Yeah. I would never say that I was great at notation. So, I'm going to break this down into each component. We have this plus C, and then I have this thing plus C. And I know they're different C's. I know. 1, 2, 3. I like that. I like that. That'll work. Yeah, I would like to use a little letter down there. I's and J's would be better, but X's and stuff are not. We haven't gotten to that point here in this class, but you don't want to put a little X down here because that definitely indicates something totally different in this class. So don't do that. I can understand 1 is good. Okay, so yeah, this thing, you know what? I'm just I'm just gonna do them separately because we're just gonna have to do that. So oh, and I'm supposed to plug in a 0 again. What is e to the 0? And e to the -0? And what's e to the 0? Okay. You win. You win. -1 on both sides. There we go. Are y'all okay with the way I'm solving this stuff? And so with these, I can now say, like, honestly, like for reals, what my answer is: e to the t minus 2, 2e to the -t plus 2, and then all this 3 stuff minus 3. So this is like the legitimate. And we're not done, but that's my legitimate prime. And then I can take that, do it again, repeat basically. So we only did half the problem so far, and already filled up the whole page. Oh yes, I will hold. I will hold. I am to hold. Because I get all excited, you know? I just like, I gotta keep going. This is so fun. You know, like, Chad, it's not fun for me right now. It's not fun. You're okay. So, are you okay with me setting this equal to that? Solve? And then that number I just basically popped in right here. So this one right here, and then I added my numbers. I should almost use a different color. So I said this and this combined together to make this stuff right there. And you have colors, so it's good. I was thinking that maybe tomorrow or the next day we can do the lab together. Of course, I want to do this stuff too, you know. So, would y'all be okay with that? Okay, cool. And y'all know that the lab won't take very long. It's more of like a what am I supposed to do kind of question. And then after that, y'all do the rest. Of course, after I've done half of it. So,
What are you supposed to do? Revolving around rather than just syllabus.
yes, yes. Well, when you go for a master's, that's called the oral examination. Yes. It's nothing to be scared of because it'll be your professors asking you questions from class. At least they say that. Right, right. Yeah, I don't think. I mean, maybe I'm wrong. I don't know if the engineering focus would have an oral examination. It's more project based, I would say.
It's writing the thesis paper.
Well,
It depends on which college, 'cause I know
yeah.
if I believe, I'm trying to think. It's too early for that.
Okay, that's fine. So, integrating e to the t minus 2t, very good. If you don't mind, I'm going to put C1 in here right now. Might as well. Negative 2e to the negative t plus 2t plus C2. And then this guy,
That's going to be just
yeah, excellent, excellent.
and then minus 3t.
And then C3. And this whole thing, okay, when t equals 0, should equal, I should probably do something like an arrow there, should equal 3, 2, 5. Okay, awesome. So yeah, let's just start breaking it down. So I got a 1 minus, a 1 minus 0. Very good. Yeah.
So that means c equals 2.
Excellent. Plug in a 0 here. 0 again. We really like polynomials, man. Polynomials make things so much nicer. And then the last one, still get that 1, still a 0. Sweet. We're basically done. So I'm gonna type in my well, I'm gonna write it. That way I have it on paper for all the silliness that sounds like. Okay, there's a lot of moving parts, even to this one. Now, the other one right before it, number 7 on the homework, was much easier because it was all polynomial. So having to solve and stuff was not a big deal. But here we got an extra step, which is fine. Sometimes I like the adventure. Cool. Yay for adventure. Adventure time. Da, 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 da. I just made that up. Don't copyright it. Yeah. Y'all have something else for the homework?
I'll be honest, this is as far as I made it so far.
That's fine. That's fine. Yeah, I mean, y'all got. See, that's one of the hard things is y'all got other classes. Well, okay, most of us have other classes, but like I can't just assume that. Oh, well, where I am, y'all are. No, that's not a good assumption. But it's tough though, you know. True. True. It is. It is a lot. Yes. Yep. I know. I can cruise around or maybe find some fun stuff. Say that again. 4? I like fun, so let's talk about it. Oh my. Yeah, I like. Oh, integrate sine squared. I'm gonna have to remember this one. Oh, you have the formula? I'm gonna try without a formula. I don't know. I'm gonna see if I can do it. And look, there's a 2 in there too. Bigger. Okay, are y'all good with this? Can I erase it? I don't mind waiting though. You good? You're good. Okay, refresh. Here we go. Okay. Okay, there we go. Well, let's pause for a second here, okay? Let's pause. Is this radio mode? I mean, just take a guess.
Technically, it wants it.
Probably.
Using Pi as needed, so I have some radio mode.
Yeah. So, okay. I know that we're not allowed. He's like, oh no. Chad, what are you gonna do? Let me show you something. We're gonna do it. I want to do it. I am gonna do it. I just want to show you like so interesting. So if we go to Desmos graphing, now this is for the final exam, not our unit exams. But go ahead. Yes, it is. Yes. I know. I am a parentheses happy person, and I hope that y'all are too. Yes. Now, you all agree that they're actually all independent of one another, right? So each category, each component does not affect the other ones. So then I could technically do stuff like this. And you're thinking, well, that didn't really work. Well, it says in terms of pi. And so you probably already know how this works. What if I divide by pi? Nope. Dang it. Oh, look, because it's a 17. That's probably going to throw us off a little bit. Okay, well, this could be helpful. That was not helpful. Oh, well, okay, there. Okay. There are times when doing this is a helpful little tool for you, okay? If you're on the final exam and and you get something like this and you don't got a lot of time, you might want to consider using Desmos graphing, just kind of see what's going on, right? Because look, sometimes you can get easy answers without a lot of work. Now, let's just say if I had like a square in there. Now, have you seen this before? 1.57? Mm-hmm.
So, Chad, the one thing I do want to mention is with this one, you made a slightly different, part.
I know. I'm just saying, if there are, there's sometimes a way to do that sort of stuff. Oh, that doesn't even matter right there. See? So yeah. And of course, sine versus cosine. I'm trying to prove a point that there are ways to help out a little bit. Okay? On the final exam. But did y'all know that Desmos graphing does this? Oh. Never mind then. Should have just asked, did you know Desmos graphing?
I play with Desmos graphing all the time.
Okay. Oh, really? Okay.
I
Fine.
used it for a couple of labs. I'm not solving this. You want to know what? This is your answer. That's what I do too.
All right. Well, I thought I was being innovative. You know what I mean? I thought it was like, oh, Chad. No, that's why y'all were so nonchalant about it. Like, okay, is he done talking? So what would be my integral of cosine? Did I hear the first thing right? Right?
Cosine goes to negative sine.
Remember, and maybe I'm wrong, but we're here and integrating goes upwards.
Oh, right. I'm thinking of.
Yeah, derivatives go down.
Yeah.
Yep, derivatives go down, integrals go up. Yep. Cool? Okay, good. So see, this is why we talk about it, right?
Right.
So yeah, I'm integrating, and again, quickly, we don't have to use sub and all that stuff, right? What do we do with the 17? On the bottom divide, exactly. So 2 over the 17, sine and retain the inside. We're going to go from 0 to pi over 2. And you can see that I'm basically just doing each component individually, right? So when I plug in the pi over 2, 17 of them. Well, here we go. So 4, right? 4 90s, 8 90s, 12 90s, 16 17. Okay, I know that's silly, but it works, doesn't it? So what does this turn into here? Very good. And when I plug in a 0, sine of 0 is 0, so everything's happy. Basically, this whole thing turned into 2 over 17. Am I right there? Okay, so we got that. In fact, that is, I think, the answer, isn't it? Like, that's it? Like, 'cause that was it, right? For that component. And then we just do the next one. You know what? We could with Desmos graphing, because I know that I was getting that weird, funky answer there, but that's just the point. Now that I have the answer, I can double check myself at least. Give me a second here. Graphing. So if I integrate, nope, not Uber, integrate pi over 2, 17t dt, and then I say 2 over 17. There we go. Confirmed. Okay, awesome.
You can also just, like, once you, for the not final exam, you can just plug it in and you get.
Oh, that's right. Yes.
At least check.
Yes. Good idea. Yep. Definitely good to double check. So then, negative sign would end up being a?
In this case, positive sine or cosine.
Very good. Divide by the 2. So just a plain positive 3 halves cosine 2t from 0 to pi over 2. Now, whenever I plug this in, I get pi. And cosine at pi is going to be a? Very good. And cosine at 0 is a? So what we have now, hold on, erase. What we have right now is when I plug this in, I got a -1 minus a +1, which is kind of weird. It's like minus a positive, so it's still negative in there. So I got 3/2 and 3/2. Perfect. Cool. Last one. Okay, so let's see. You're going to challenge Chad now here. Can you remember how to do sine squared, Chad? Give me a second to think about it, okay? There are formulas. I know there's a formula for it. Hold on. I'm not going that far yet. Is there a trig sub formula for that?
There's an identity for that.
Yeah. Give me a second. Hold on.
I was just clearing my throat. I wasn't trying to say anything. I'm sorry, Chad. I'm sorry.
You're fine. It's cosine squared that I'm thinking of with those other identities.
I know cosine squared and same thing. So one is positive, one is negative in a certain spot.
Give me the formula, bro. 1 minus cosine 2x. Just like that? T, of course, but yes. So that's it? There's no other squares. Is that 1/2 coming from this guy?
No, it's coming from the sign. It's part of the identity.
So then this would technically be, because it's u sub, then we would have a 2 down there. No. Hold on. So you're saying that's x, but that would be an x. Gotcha. Okay. Let me write that down so that I'm clear. Go ahead. Oops. Here, let me can I start over? Like I need a formula, right? So let's do that. So I'm gonna do a little star. Sorry, I say, oh, it's a formula. So sine squared x dx is 1/2 1 minus cosine of 2x plus c, basically, right? Is that correct? Formula correct? Yes or no?
No, it's just you're substituting sign squared instead. Yeah, so you still have to integrate. It's just negative.
Oh,
Yeah.
you're saying that. Okay, hold on. You're saying this is the formula.
Yes.
Oh. Well, then it's easy after that. So let's be careful though, because we have a 2t, right? So then if it's a 2, then that would be a 4, but then really in a way I need to do some kind of like u sub stuff. No, I think I can directly do that. I could just put a 4 here, can't I?
Yes.
Because I'm not actually taking a derivative. It's just going to be, okay. Really? If I had a 2 there, and then I had the cosine, okay, well, I'm trusting y'all. I can't remember, but that's why we go to pre-cal to learn it and forget it. So, yes, and then you learn it and then you forget it again, right? Yes. Exactly. 1 minus cosine of 4t, right? dt. Am I now correct about that? Yes. Pull out the 1/2. That's an easy one. And then this is the same as the other guys. But I'm going to finish it up at this point, right? Okay, so here we go. 1/2. And then I have t. Oh, I see. And the negative cosine went to a negative sine. I'm still feeling a little iffy about this one. But let's plug the stuff in. So there's my pi. That's what was making things all like a little bit weird. 4/90 comes back to a 0. Oops. Yeah, that'll work. So then I got pi over 2 minus 0. Then when I plug in a 0, I get a 0 and a 0, right? So it doesn't matter. So pi over 4. Still nervous about it. Okay. Cool. Looks good. Thank you, guys. Thank you. Thank you for the formula. Okay. We got more time? No. No, Chad. 1 minute. We're done. All right. Are y'all good, though? I'm wanting to do the lab tomorrow, okay? If possible. If not, I'm just kind of making sure we're all here, if that makes sense. As much as we can get as everyone here. So then lab tomorrow, probably more of this. Wednesday, probably more of this, unless we get super bored. And then we can jump into the next chapter. Cool. Thank you, guys. Y'all have a great day.